Hi, I'm Enoch from Synthesis. In this video, we're diving into the world of financial data integration, walking you through the setup and deployment of a powerful tool we've built, the Synthesis Fix Source Connector. But before we jump in, let's talk Fix. The Financial Information Exchange Protocol is the industry standard for communication between trading platforms, brokers, and other financial institutions. It allows them to electronically exchange critical data like orders, quotes, and trade confirmations. But here's the catch. Fix has different dialects or versions per se. Each provider you connect with might have a slightly different way of implementing the standard. This can be a headache for teams who need to build custom integrations for each variation. And that's exactly where the Synthesis Fix Source Connector comes in. It's your one-stop shop for integrating fixed data, regardless of the specific implementation. With our dynamic driver functionality, you can easily switch between open source and even custom in-house built engines for your specific situation. This flexibility saves you development time, and most importantly, streamlines your data integration process. In this demo, we'll showcase how it works. I'll walk you through setting up the connector in a Confluent Cloud environment using an open source engine. Then we'll switch gears and show you a real-world case study of using a custom-built engine that we have for a banking client. All right, let's get into it. So, here we find ourselves inside of our Confluent Cloud environment, right on the connectors page. The first step will be to go to Add Plugin. Here, you reach a page to add the custom connector plugin. We can see there's a couple connection details that we need to provide, such as the plugin name, plugin description, the connector class. For the connector type, which will be a source connector, we will then have to add the connect archive, which is a folder of the jars needed to run the connector. Finally, we have sensitive properties. Remember to add values such as username or password, depending on your fixed connection. Finally, we'll agree to the Confluent disclaimer. When you're done, your page should look a little something like this. Next, we'll click Submit. This will upload the connector to Confluent Cloud. Great. As we can see, our source connector has now been added to our Confluent Cloud environment. To create an instance of it, we'll hover over the connector and click Get Started. Our first step will be to generate API credentials, either by using existing credentials or generating a new pair. Here, we're presented with a place to add the actual configuration parameters for the connector. You can add these in manually by entering each key and value pair for the connector, or you can make use of the JSON quickstart that we've provided inside of the quickstart file. It should look something like this, specifying various values such as the connector class and various fixed connection details. Next, we'll make sure to add an auto schema registry. For the key converter type, we'll click None, and for the value converter type, we'll click Avro. Great. Now that all our connection details are there, we'll continue. Here, we're presented with a point to enter in our connection endpoints. This will be a list of endpoints that our source connector will need to reach out to, such as our fixed provider. In this scenario, I'll be using one from a simulator website called app.fixsim.com. Next, we'll click Continue. Next, we reach the connector sizing section. Because of the nature of fixed sessions, you can only have or maintain one fixed session per connection details. Thus, we'll only be making use of one task. So we will click Continue. Now we can review the different connector configs and details that we've specified, making sure everything we need is implemented. Remember to include any sensitive properties that you may have. For this instance, we are not using login details. Great. Once we finalize the connection details, we'll see the connector being provisioned inside of our Confluent Cloud environment. This may take some time, but we'll be notified when it's done. Great. Now our fixed source connector has been provisioned and is running in our current cluster. To check any of the logs, feel free to head to the log section and check over there with real-time updates. Great. As we can see, messages are currently being processed. So let's switch over to our simulated fixed provider in this scenario, app.fixsim. As we can see, incremental market data refresh requests are being sent, as well as heartbeats. We can send another heartbeat or various messages, such as a market data request as well. Let's quickly scan over to the topics, where we can see the market data request topic, as well as the incremental refresh, which should have messages coming in. As we can see, there's a steady stream of messages being produced to the topic. If we click on one of these, for example, we'll be able to see the decoded fixed message, showing information such as the begin string, the message type, as well as the sender and target comp IDs. Let's return back to the topic session and look at the market data request that we had sent. If we go to messages and look from beginning, we'll see this most recent message, which has the same values. As we can see, the market data request ID is 55 in this case, which matches what we had sent before. And just like that, you seamlessly have Fix messages being streamed in from whichever Fix provider you may have into Kafka topics, ready to be transformed and used for any use case. Now, let's see how this dynamic engine functionality works in a real-world scenario. One of our banking clients received Fix data. This data has a very specific format, but unlike most Fix implementations, it didn't rely on a predefined data dictionary. This presented a challenge. Traditionally, developers would need to manually code the message structure for the specific format, but it's a time-consuming and error-prone process. And that's where the power of our Fix connector comes in. Thanks to the dynamic engine functionality, we built a custom Fix engine specifically for this client. This engine can then analyze the data stream itself and dynamically generate the necessary classes to process the Fix messages from SmartTrade. This custom engine seamlessly integrates into our synthesis Fix source connector, and together, they decode the Fix messages. Our connector uses the custom engine to understand the specific format of the data. The decoded data was then transferred into Confluent Kafka topics. Using the standard Kafka JDBC connector, the data was then transformed and loaded into a timescale DB, a powerful database optimized for time series data. Finally, this real-time data was then used to update their internal dashboards with their already existing infrastructure. The result? Our client achieved seamless integration of their Fix data, enabling them to build dynamic dashboards with real-time information. This not only reduced the complexity of the data pipeline, but also significantly sped up the development process. Importantly, by building a custom Fix engine in-house, they also maintained complete control over the data security. This is just one example of how our Fix source connector and its dynamic engine functionality can simplify the Fix data integration for your financial institution. So, this was a comprehensive deep dive into the synthesis Fix source connector, a Kafka source connector that streamlines the data integration process of various Fix systems through dynamic engines. To experiment for yourself, feel free to use the Quick Start trial, and to pursue development of your own Fix engine, feel free to reach out to Synthesis through our contact information. Thanks for watching. Bye.